Great, great. And hello to everyone watching this stream tonight. If this is your first time, definitely let us know. Also, let us know where you're watching from. It's always kind of fun to see where folks are watching from. Yeah, speaking of which, Mohit, where are you streaming from today?
New Jersey, the East Coast. That's where I'm streaming from. How
Excellent.
about how about you? Obviously, you're in
Yeah.
Chicago.
Yes, I'm in Chicago. I've done like a little bit of traveling, so things slowed down a bit. But I'm really excited to be back in Chicago. There is a really strange 50-degree night. It's above freezing. Sorry, 50 degrees Celsius. I know we have some uh, folks from other places, and in other places it's normal to use Celsius. Um, yeah.
Nice. It
So
uh, it was really hot here for the last couple of days, but it got really cold now. Uh, I like the cold,
Oh,
so
well, maybe that's why it's really warm here because you have all our colds.
no, that's funny.
Yeah. Yeah. So, Mohit, tell us a little bit about yourself. Just so folks know, we're actually super lucky. Mohit is a Google developer expert for both Android and Kotlin. That's two entire categories. So, really exciting stuff. Yeah, Mohit, can you tell us a little bit more about Square's molecule library and how it relates to Jetpack Compose?
Yeah, that's what my talk is about. So I explored the molecule library. Obviously, Jetpack Compose, since it has come out, I've been learning more about it. And this library is about building state flows. And when people think of Compose, you might think that it's just a UI toolkit, but it's be used for other things. It's a general purpose tool under the hood. So that's that. I'll share more about that. So I built for the past 3 months since November of last year. The way I started to explore this library is that I like to work on side projects. So I worked on this side app, and which was just a simple app, and I just explored how you would utilize basically this pattern that the molecule library has, and just to explore and learn more about it. And I'll just share my learnings in my talk. I think you're muted,
Ah,
and that's okay.
classic. Well, that's all wonderful. So yeah, this is just kind of like this is Square's new, like one of their newer libraries coming out.
Yeah, I
Yeah,
guess I should say Cash App. I guess so. Cash Apps,
yeah, yeah,
which is
yeah.
also block. So which is there. This is one of the libraries that was released. It's in 0.2 version of it. So
Yeah.
uh, there was a blog post released when it came out. So several companies in that blog post they highlighted that are trying it out, like Pinterest, for example.
Oh wow.
So it
Yeah.
looks
Love it.
interesting.
Okay. All right. Well, I can't wait. And what I can do is, I guess, like find a link to Square's molecule library and post it so folks can look through it as well.
Yeah.
Yeah, but that's super awesome. Can't wait. Like, I feel like if I ask any questions, I'm like, I could just wait till the end to ask these questions. Maybe I could just watch the
Right.
presentation. I can't start off with all that. But yeah, really exciting. Really looking forward to it. Yeah, and I'm sure like some folks, I'm not sure, like feel free to comment, but like if you're using like Jetpack Compose, or maybe you're not using Jetpack, feel free to comment because I think that's always helpful for speakers so that they're able to make sure that they're giving the right level of context. So feel free to do that. I myself, I am using Jetpack Compose, so this is something I am really interested in learning more about. And yeah, So here's what we're going to do. Mohit, I'm going to boot you off for a couple seconds. We're just going to run through the logistics and then I'll hand you the floor.
Okay,
Yeah.
sounds good.
And of course, please feel free to ask questions in the chat. Mohit will definitely be looking at the chat and answering it. So, feel free to participate. It's really great to see so many people online today. Okay. We'll see you in just a few minutes, Mohit.
All right.
All right. All right. So, for those of you that are just joining, this is the Chicago Kotlin user group. We have Mohit Sarveiya guesting us today. He's a Google developer expert for both Android and Kotlin, and he'll be talking about using Jetpack Compose with Square's molecule library. All right. So, if you've never attended a Kotlin user group, this is what we're about. We believe in being inclusive. So Chicago Kotlin User Group is an inclusive group. It means that we are curious, we encourage asking questions, and we avoid assumptions. And we want to do, even in pandemic, anything we can to be able to continue to grow trust, empathy, and friendship. Okay, do you want to give a talk? I did not post that short link in this slide, so that was not great on my part. But there should be a link right in the description of the YouTube, so please be sure to look at that. We do have an open CFP for the 2022 year. We're always looking for new speakers, and it's a super great way to expand your network. Looks good on a resume, and it's a super safe space to practice talks. Folks are super nice, and yeah, I mean, if you have like a work presentation, software engineering experiences, or even like a side project you want to share, all of that is welcome. We love it. I'll be sure to post that link as well, like in the chat while the talk is going. If you're not connected to us via the Kotlin Links Slack, we're on the Chicago channel, and we're also on Twitter at Chicago Kotlin. So please be sure to follow us. Yeah, so live interactions, please make use of the YouTube chat. Mohit will be looking for questions on there, so please feel free to ask at any point. There we have Mohit's username for Twitter as well as the Chicago Kotlin one. Please feel free to take screenshots and be part of the conversation. Okay, I think that's just about everything. Mohit, I'm going to let you take the floor.
Okay.
All right.
All
Thank
right.
you so much.
Thank you.
Mm-hmm.
Hi. So thank you for having me. My presentation, as I said before, will be on how to use the recently a library that was released by the Cash App team called Molecule. I'll share my experiences on what it was like to use the library and how it works, how do you set it up, how it also works underneath HUD. So that's what I'll share. How do you set it up? How to use it? How do you go about testing it? And then lastly, what I'll do is that I'll share basically a sample app I made and then how I implemented it when you have an app that has multiple screens. So let's start with what the purpose of this library is and the problems that it attempts to solve. So suppose you had a problem, you were building an app that, for example, suppose you were building an app where you had to display a profile screen. And to display the screen, you basically have to aggregate multiple streams of data. So how would you set that up? Suppose that in this screen, the data is retrieved from multiple flows. So it could have flow one or flow two. And to display this data, you have to have some business logic that works with these flows. So the way you may set it up and is by you could have the screen is represented by a composable function, and one way you could set it up where you have this composable function that takes in both of these flows, and you're setting up, I'm doing collect that state, and basically I'm setting up some default values for it. So with this approach, there are pros and cons, and one of the cons is that it kind of mixes business logic with your view layer, where I am specifying my default values in here. And is there a better way to do this? Is there a way to separate this out, basically? So there are different approaches you could take, and one approach I'll show you how to use it, how to do it with this library. So with Molecule, the approach that it proposes is that what you have here, what you have is a presenter. You have a composable function that knows how to generate a view state, a model, basically for your view. So the presenter, this composable function, takes in a flow of events, and it could be any type of event. Could be some data that's has that was fetched, or something else, and it knows how to take this flow stream, and it could apply some business logic to be able to generate and return a view state. So the Molecule library, what it does is that it takes this presenter, this composable function that you would create, and it knows internally how to, it's able to build a state flow. It builds a state flow and gives it to you. And excuse me, and when this composable function, this presenter, every time a recomposition occurs, it's invoked to generate some type of a view model. Sorry, a view state. So this Molecule that this library provides, basically this component that's called a Molecule, which I'll show you, is able to, what it does is that it generates a state flow, and it takes in this presenter, and it gives you back a state flow. And we'll look at how that works. So this is the approach that with Molecule that you could take. So the purpose of this library is to use compose to build state flow streams. So, and that might sound like confusing, because you may be confused that like compose, the word term is used interchangeably for the UI toolkit, and also like it's also used as a term for saying that it's also the under the hood compiler plugin. So I want to clear that up beforehand. There's a distinction between these two different things, that it doesn't really have to just be for UI. So Compose, is also, it's a compiler plugin. It's a general purpose tool for managing a tree of nodes, right? And they provide you with an API to be able to do that. It's a compiler plugin. And these nodes, they could be anything. They don't have to be views, right? So when you look at the community, if you were to search, you'll find there are a couple of many different tools out there that use this Compose, this general purpose tool, without the context of views. So, and Compose UI, which was what everyone knows, about and considers when thinks about when they think of Jetpack Compose, which is the UI toolkit. And the UI toolkit, in this scenario, the nodes in this tree are views and view groups. So there's a distinction between those two different things. So in order to learn more about what I just spoke to you about, both distinction between these things, check out the blog post at Jetpack Compose by Another Name that goes into the history behind these projects and how the name came about. And there's also Compose from First Principles, which talks about this the plugin and this idea of having on how it uses, how the plugin is used, this tree of nodes. So check out both of these two resources to learn more about that. So Molecule, it's a compiler plugin, and what it does is continuously recomposes, based on some clock that you provide, which determines when the recomposition occurs, and it's able to take that presenter that I showed you, a composable function, and generate a state flow. And I'll show you more of how that works. So let's look at some very basic example of setting up Molecule and being able to to launch molecules. And what does that mean? So suppose in this scenario, suppose I was tackling this problem with molecule, how would I go about doing that? So in my setup, I may have a view. It doesn't have to be Jetpack Compose. When you look at the example that molecule has, it doesn't actually use compose in the sample that they have. So it doesn't have to be compose. It could be, if you want, at the view layer. And what you have here is that you have this component, this pattern, a method that called a molecule, launching a molecule, that this method, this pattern allows you to generate a state flow that the view is listening to. So you give it basically a presenter that has all the logic encapsulated, which knows how to generate a view state, and the molecule, and this molecule takes that in and gives you back a state flow. So, and this presenter could inject any number of event streams that you want. So this is the setup. Now, how do you implement each of these different things? So let's look at that. Let's start with the presenter. So my presenter is going to be a composable function. So a composable function, which is going to return some model. So my model is a CO class, could be loading data or anything for your use case. So my presenter is going to return this, and is going to basically take these streams of data, and it knows how to generate a view state. So it takes this flow. In this case, I may have a profile page where I'm displaying a post. I'm displaying the number of likes. So it takes in both of these flows, and it goes in it and gives it a default value for them, using collect that state. It basically also I'm specifying a default value of 0 in this example. So collect as state is a way to bridge basically flows to compose observables. So what you could do based on these flows, it returns some particular type of state. For example, if it's null, it might be loading. If it's successful, if you have some data, I know I'm going to get back the data you got back. So this right here is a very simple example where I'm using these flows to basically determine a model, basically. So you could have a lot more different logic based on your use case. And this is my presenter. Now, I need to be able to take that presenter and basically create a state flow from it, basically. And the way that I'm going to do that basically is that the first step to do that, and this idea is called launching a molecule in this library, is to define a coroutine scope. That's the first step. So I'm going to define a scope which has, in this case, a dispatcher. My dispatcher is the main dispatcher. And then the second thing that you need to specify is a frame clock. And you need to specify a frame clock because it controls allows you to control when recomposition occurs. And there are two types of suggestions there on which frame clock to use. You could use Android UI dispatcher, or you could create a broadcast frame clock. So what you need to do is add it to this context using the plus operator. So I have added that to my scope. So the next thing that you need to do is basically to use the launch molecule method, which will return me a state flow. So this library is actually very, very simple, and it provides you with an extension on a scope. And it's called launch molecule. And it takes in a lambda, takes in a body, which is this presenter, this composable function that knows how to generate a model. And what this returns to you, this scope.launch molecule, is a state flow. And I'll show you underneath the hood how that generates the state flow and how that works. So this is the state flow that we could now give to our view and declare in there what, based on success loading, what to show. So anytime a recomposition happens like this, the molecule will push things out to this state flow. So my view then is going to take that state flow, and then I'm going to just give it to, I have one stream, one source of truth of how, of which views, based on, what to show based on a particular view state. So I'm going to collect that state on my models and use a when to declare for loading and for success what to show. So this is the pattern. This is a simple pattern basically that the library has. So the library presents. So where you have a presenter and then you have a view. Now you might be thinking, obviously, how do you, if you want to use like a Jetpack view model, if you're using that approach of architecting your app, how do you go about utilizing this pattern with that approach? So there is an app. There is a good example that's in the TV app, and this link, I'll link it out in my presentation, which has an example. It's an open PR which has an example of how to use this pattern with a view model. And let me share with you basically how, similarly how to do that. So suppose my view model, I have a view model, I don't have a presenter, and I might inject things into this, So inside of here, one approach you could take, which is create a scope, a molecule scope, which I'm giving it the view model scope, coroutine context, and I'm also giving it the frame clock. I'm going to utilize this scope and launch a molecule. I'm going to create this state flow that my view model is going to expose. So I'm going to do molecule scope, the launch molecule, and I'm going to have the same logic that I have in there. I'm going to have my events, my flow of events, and that I'm listening to. I'm going to generate basically a view state, a model. So one thing you'll find is that when you look at that TV app in that example, you'll see is that it also uses, you may have a use case where you need to use a launched effect. And in there, it has examples in there of using launched effect and listening to events, and then also coming up with this model that this state flow will have. So you have a state flow in here that you're going to give to your view layer. So this is a way to use to launch molecules, and this is a pattern for using it in MVVM in your view model. So there are two things that we looked at so far. We looked at a very basic example of how to set up a presenter, how to launch molecules. So another thing is that the view layer doesn't have to be composed. When you look at the sample in the library that's there right now, it doesn't actually use compose at the view layer, so it doesn't have to be. So we looked at this basic example, and now let's look at basically how to go about writing tests. So what we want to test in here is that with this molecule that I'm creating, this state flow based on a particular events that this presenter is taking in, does it generate the right model that I'm based on the events that are emitted by these two flows? And the molecule library provides you, that's what I want to test right here, this setup right here. So the molecule library, what it utilizes, it provides you with a module for testing that you need to include as a test dependency. And it's built, and really nice thing is that it's built on top of, it utilizes this library by Cache, also called Turbine. So Turbine is a library that is used for testing flows. And it provides you with an extension on a flow called test. Provides you with a really nice API. And what you could do is that when you go to test flows, you could do you could call methods like await item, await error, to basically to verify that your flow is emitting like one by one what you expect it to. So this is a really nice library that turbine called Turbine. So in order to be able to test your molecules, you would add in your build script this test implementation like this. And the question is now, how do you set up your tests? So let's look at in our example let's look at like a very simple use test case, which is the test case of loading, generating the loading basically view state. So first thing that you will do that you should do in your test is set up these flows, shared flows that's going to be for these events. The reason why you would set these up is that in your test you could like emit things to it, and then after you could assert based on that emission, excuse me, was the right model generated. So this is the first thing you do. You create these state flows like these shared flows. And then what the library provides, it's a really nice API, and the method is called test molecule. And it takes in basically two things. The first thing that is going to take in is your presenter, your composable function, profile presenter. And it's going to take that in. I'm going to pass it these two shared flow, these test flows that I made right here. I'm going to pass those things to it. And this presenter knows how to generate a state model from them. So the second lambda is where I'm going to do assertions, right? So underneath the hood, this test molecule knows how to take that presenter and generate a state flow from there. And what I'm going to do, and this is a simple example of it, which is a simple example, and a wait item is a method in Turbine. And what it does is that a wait item says that grab me the first thing in the flow. So underneath the hood, the way Turbine works is that it takes the flow and it basically collects from it, and add things to a channel. And it's an array based channel with some size. And I could query basically in that channel, pull things in there on what the flow emitted, events basically. So what I've done here is that what I'm doing here, a wait item is basically pulling something from the flow, the loading state. I'm doing an assertion on it. Think about it. Think about our code we had in our presenter. Right now in our presenter, we had code. We had a null check. And let me go back to that. We had this null check right here. Look at that null check. No, if it's null, then it's going to return a loading. So that's what we're doing here in this assertion. So that's a simpler test case. Now what if I want to test the case of actually getting some data? How do I do that? So before doing an assertion on that, I'm going to post basically data, an event to the post flow, right? The shared flow. And after pushing it to that shared flow, and the next thing that I'm going to do is that I'm going to do an assertion. I'm going to wait item and call a wait item, which pulls in the thing that was emitted from the state flow. And I would assert that it's a success. So this is a very simple example of how to set up tests using molecule like this. You would do this for any of your view states in your logic of your presenter of this composable function. So we looked at two things. We looked at how to set up a test. We looked at how to use Turbine, and it's a really nice pattern that you could use. So now what I want to look at, when we looked at this simple setup, how does it I want to give you a glimpse of how it works underneath the hood. So the way it works underneath the hood is that, as I said, that the compose is a compiler plugin, general purpose tool, and you could hook things in. You could hook recomposers in there, and there are 3 steps that it takes. And I'll show you how these 3 steps are taken in underneath the hood. So what this library does is that it provides you with an extension on a scope called launch molecule, which is returning a state flow. So it takes in basically your body, which is the composable function. The type T is basically your whatever model you have, whatever model it is. So what it does is that it generates the state flow, and the way it generates is inside of that source is that it creates a state flow object internally, and this is the state flow object which is returned to you. The question: why does it generate create a state flow internally so that it could push things to it? It will use that recomposer and then call set content on it, and basically whenever recomposition happens, it will push things to this flow basically. So this is, as you can see, that this is what it's doing here. It's pushing this out. Any state update change, any changes to this state flow. So and the body that it takes in is a composable function. So the first step that it does is that it sets up a recomposer. So recomposer, this is a part provided by the API, provided by the compiler plugin, the compose, and it takes in a coroutine context, right? And this is used for scheduling, recomposition. This is a scheduler for performing recompositions. And the next thing, it calls a method call which you give, your recomposer to. And using this composition value that's returned here is going to be utilized to basically fire the body, basically, all the logic in there. And so the next step that it does is that in order to schedule recomposition, it launches a coroutine which awaits an invalidation of any associated composers. And the next thing that it does is sets up a global listener on a snapshot. So when this is called when a state object is modified, basically. So it sets that up. And then the last thing that it does is basically, as I said before, it calls the set content on the composition. And basically, the body is your composable function. So it's basically invoking that and then passing the return basically to the state flow. So when you look at the source, the source of this plugin, it's actually it's not really that complicated. I highly recommend to learn about Compose APIs, to learn how it works underneath the hood. And that was the benefit of looking at. I'm not an expert on how still learning on the internals, but this is what I was able to learn from looking at the source code and walking through it. So then, ultimately you get a state flow back. So this is how launch molecule works underneath the hood. And now, after looking at the internals, what I want to go through is a sample app. And what I showed you so far was something that's very simple, like something that works when you have a single composable function represents a screen. But what if you had an app where everything was fully built using Compose? And in that scenario, in that approach, there are a lot of open questions that come up that I'm still tackling with, that I'll just share as a food for thought with all of you. So the sample app I made, the purpose of it is to learn, just to try out different libraries, and I used it to try out this library to learn Compose. And basically, in this sample app that I'm going to show you, this sample app, what I showed you before was only one presenter. But what if you had multiple presenters? What does it mean? How do you set up launching molecules with multiple presenters? And that's the question. That's the interest part in terms of architecture. So I built a simple app based on my hobbies outside of programming, which is golf. So I built an app that's something I always wanted to build in my life, which is an app that displays basically a list of scores, and it recreates a historical tournament. I guess the question is, why would someone want to do this? I don't know, just for the pleasure of fun. So, so the first tab displays a list of scores, and this list is updated by a stream that is exposed by a GraphQL server. So the players tab displays his own information, everyone that's on the tournament and the weather for a particular day. So the whole tournament is simulated. I'm able to control the simulation and the time, and that was the most, other than using Compose, that was the most interesting part about working on that. So there are three tabs, and each tab is represented by a composable function, displaying the scores, displaying player info, and weather info. If you think about it, and in this app, you may have more. You could also dig deep down into these screens, and you may have more screens. So this is the way it's set up. It's a multi-platform application I made. So I've also been learning iOS, to be able to learn. Also wrote an iOS app. So both of these things, they share common components: the Android app and the iOS app. And the common components that are shared is a stream that where you could control how fast it basically gives you back data as the day progresses. So it's a simulation basically, and this is backed by also a GraphQL server that I created for this. So this is a personal project, by the way. So what this does is that the way each of the screens are set up on each tab has a presenter which takes in a stream of events. And this is the same setup that I showed before, and it generates some model basically for the view. So the first question that comes up is that when I was building this, I wanted to build in my presenters in a way where they partake in dependency injection. So there was a associated blog post that was published as part of this library, which gives you a hint of and a example which is used in the Cash App, and I wanted to try it out, something similar. So basically, rather than having a composable function, rather than having the presenter just be a composable function, I changed it so that I could inject other things into it. I made it into a class. And this class here basically has this composable function inside of it. So each presenter has this composable function, and it's called present. And it takes in a flow of events and it returns you a model. Now the problem is that how do you build an abstraction? There was a hint in that blog article, and I was thinking about of a certain abstraction that all the presenters use, and I was thinking about how was that built. So one thing I thought of is basically that for each of the presenters for each of these screens, what it is, what the way you could set it up, and I'll show you how do you create a pattern basically for setting this up. You could create an interface like this. So each of your presenters are utilizing. So this is a generic interface where you have two generic types: the event and the model that it returns. So each presenter would utilize this basically. So you have some contract with this that all of your presenters are adhering to. So, and it's a composable function called present. So the way I set it up is that I have my presenter now, like this is a injectable. I'm using dependency injection. I could give it any type of utility I want also. So I may be like tracking analytics. I could inject that in for this presenter. And now the question is, when you have this setup, this is the setup for each presenter for each screen. And this is the pattern that I'm following. The question is now, how do you launch molecules, as I showed you before? So the way that I set up the app that I explored was each screen is I'm using Jetpack's navigation, library, and each screen is a composable function that I'm giving to my navigator. So I have a main navigator that's able to navigate to these three different things. And all of this is set up at the activity layer. This is an architecture setup where you have one activity and you have everything else is a composable function. this is an exploration of how things would look with that setup. Is that, what are the pros and cons and the challenges? So the navigator takes in for each tab the state flows basically. And what I'm doing in there is that at my root layer, what I'm doing is I'm creating this navigator, this root composable function. And in here at the activity layer, I'm creating or launching a molecule for each of my screens, for each of the tabs. The first tab, and this is the second tab. And the problem there is that when you have multiple screens, not just three, the problem becomes that this starts doesn't scale well, because now I don't want to have one activity with a lot of launch molecule methods. So one thing that I'm working on, so this is an open question, is like, where do you put this if you have more and more presenters, you want to launch more and more molecules? I'm doing it at the root layer, basically at the root activity level. And the question that I'm still exploring is that how do you do that in a better way? So I have it at my activity layer is where I'm setting all this up. But it doesn't scale when you have multiple screens, if you had deep nested screens. So and that's one of the challenges that I found with launching molecules. So yeah, how do you set up launching molecules for many presenters? So that's an open question. The other problem that I found is that I only have three tabs, and each those screens like has a presenter that's associated with it, and I am injecting those presenters at the root activity level. The problem is that when you have multiple presenters, more than two or many or 10, it doesn't work that well. Where do you inject it? Basically, you when you yeah. So I'm still trying to work on finding a better pattern for that. So how do you? One open question is, how would DI work? When in a setup where you have one activity and everything else is a composable function. You could take the approach of still using fragments if you want, or something else. So this is the approach that I was exploring. Oh, this is an open question. So I have my friend Bill, who's a really nice guy, and I reached out to him just to share my learnings on this using this library, and he gave me really nice, great feedback on the project that I was personal project I was working on that I just showed you. And Bill, shout out to Bill for his time, and he also tweeted for folks who are looking at Molecule plus Compose UI. You don't really need Molecule to run Molecule.business logic from within your Compose code. And there's an example in there of utilizing. You don't have to launch a Molecule, but you could still utilize this pattern of having a composable function. With that gives you some view state. So based on working with feedback from Bill, another way I could implement this rather than using launching molecules is to wrap my flow, basically my simulation flow in a remember, and I could give it to my presenter and then ultimately give it to my screen, my composable function. I could also, as in this example, give the presenter directly to my screen. So that's something else. That's another approach that I learned about. So I want to conclude with that. So in this presentation, I hope I just shared my learnings from using this library, a library that I'm still exploring. I'm not 100% expert. I just shared what I learned. I shared how to set up this library molecule, how to go about testing it, and shared things I learned from how the internals work, and just an example lab where I use the example lab just to explore this library. I hope so. This library, these are some resources that I'll link in my slides. I wrote a blog post about everything that I just shared, and you could check that out. It's called Using Jetpack. This is the name of the title of this talk. Also, check out Molecule Library itself. The release recently it got updated to 0.2, and there is a open PR in there on look forward to more samples and recipes being added and gotchas that I'm also still learning about. So the library is very much in its early infancy, but this is a great pattern and lots of potential and hopefully, yeah, check this library out and try it out. And I hope that was helpful to you. If you have after this, I answer any questions at the best of my ability. And if you want to check out my blog posts, where in addition to speaking about Compose, I also share Swift UI and how to handle state in Swift UI. I also have a lot of content from my experience on using coroutines and gRPC and all those topics. So, and if you have any questions, if you're looking for mentoring of any type, please reach out on, hey, it's Mohit. Actually, a couple of weeks ago, I was helping someone with this library, setting up this library and helping them in their app on how it potentially works. So if you need help, reach out to me on my Twitter handle. And I want to say thank you to Amanda and the Chicago Kotlin user group for this opportunity to present here. Thank you. That's it.
Thank you, Mohit. That was an awesome presentation, super well detailed. Can you hear me? Sorry.
I could hear you. I said thank
okay.
you.
Yeah, you're welcome. It's well deserved. Yeah, no, it was a great presentation.
That was a big sigh of relief.
What do you mean? This is like a low pressure environment. I know it's stressful on
always
camera.
always get the butterflies no matter what.
Yeah.
And
yeah, that doesn't change even behind the camera. And like it's even worse sometimes because you can't really like see like get a vibe check from the audience. You're like, am I doing bad? I have no idea. But I promise you, you're doing great. I thought the presentation was wonderful. People, they got questions.
Oh man.
Yeah.
Let's see. The first question is actually a remark from James. I'm watching from Flows Mower. Well, thank you for watching. So the question is out of scope of this presentation, but I'm wondering molecule can be combined with the navigation component. Yes, my example has, although navigation component, I mean, it's very distinct from what molecule is doing. Molecule is for generating a state flow. And yeah, I mean, you could try that out. I mean, So that's my answer to that question. The next question is, does Chicago Kotlin user group hold any online meetups? Well, this is one. So, right?
Yes. Yeah, this is technically an online meetup. We used to hold like stuff in person, and then this is just basically what we've been doing. We do have some ideas to expand. I'm sort of in need of volunteers to be able to expand, so a bit of a limited capacity. I think like this is something that we can gear up for. Yeah, it's probably good to it's the new year. It'd be great to check in with folks and say, like, hey, we've been doing this format for a while. Would anyone be open to trying new formats? I think with like a lot of like the technical constraints and stuff, like that's really just like the hardest part. But yeah, if you have ideas, definitely like reach out. Yeah, definitely through the Chicago Kotlin Twitter. That would be a great place to do it. So yeah, just let me know. Or feel free to put comments in the YouTube section as well. I forget that. We also do that. Yeah. So let's see. Okay. I actually have a question myself.
Great.
Yeah. So in terms of working with the generated state flows, are we working with like implicit hot flows or cold flows?
Well, the state flow is a hot flow, right?
Right. Yeah, that's true. It
So,
is a hot flow.
and that's it. The
Yeah.
events you could, as you saw in the test, the events could be, are hot flows, shared flows.
Mm-hmm.
So to answer your question, it generates a state flow. I guess the question is, does it generate a shared flow?
Mm.
Uh, you
Oh,
could set that
for
up.
oh, sorry. Yeah, go ahead and answer your question, but also there might be some viewers who might be less familiar with what all this is. So be sure to differentiate what these all
Oh
are.
yeah.
Yeah, yeah.
So a state
Mhm.
flow and a shear flow, they're both hot flows, but they have different characteristics, both of them. So in a state flow has this characteristic of conflation. So a state flow,
Mm,
whenever you push something to it, it stores the latest value in an internal cache. And suppose you had like multiple back-to-back emissions to it, you only get the most recent emission on the client side when you're reading from it. So that's the behavior that it has, equivalent to, if you're familiar with RxJava, like distincting and distinct values. So on the other case, the shared flow has a lot more features to it, where you could basically specify that it's a hot flow. I could push things to it. Suppose I declare a shared flow and I have two consumers, right? And I'm pushing things to it.
mm,
And then after a couple of minutes, another consumer comes in and listens to it. So I could set up a replay that for like later subscribers, I want to replay a certain number of emissions, like 2 or 3. I could also, with the shared flow, has this feature where, like, you could set up a cache, like a buffer. I want you to have some specific cache size, fill it up, and when you could specify, as you're sending things, it will store them in the cache. And like, and what should happen when the buffer fills up? Should the coroutine suspend, or should it drop the oldest or the latest? So those are the two features. Those are the feature set of both of those types of streams. So in the case of molecule, is that you saw that it generates state flow. So a state it this it's generating a state flow. You could have it as a shared flow, I guess. But there might be some complications with that. I don't really know. But you could try it. So I mean, but in the world of UI, whenever you're exposing, a flow of view states, you want to go with basically a state flow because of this behavior of conflation. That's what I think.
That's wonderful. I thank you so much for explaining all that. I think it's really well informed. I think it makes a lot of sense. And I guess I'll just like leave with maybe like one last question. And that question would be, this library just seems pretty awesome. Where do you see potential in it possibly going into like production in the industry? Oh, it's already being used, right?
Yeah, in the blog, it looks like it's used in the cash app. From that blog, it's used
Mhm.
in various places. I
Okay.
think
Yeah.
I think there is a lot of exploration to do with it. I don't think it's ready for someone to use it in production
Hmm.
right away in something complex. Because I think that you
Small
could,
projects for now.
yeah, for
Yeah. Yeah.
projects work.
Yeah.
But I think there's a lot of great potential for the library, for the pattern.
Yeah. Awesome. I thank you so much, Mohit. Really
Thank you.
appreciate you for your time, and the presentation was a really great presentation. And thank you all for joining us tonight. I hope everyone has a great night, a great week, a great February. There will be another talk in the near future, but don't forget, we are accepting, we have an open CFP, so we are accepting talks. Please send us your talks. Thank you so much, Mohit. Great talk again. I really hope to be able to edit all the stuff out. I have a feeling that there's going to be some copyright issues. Yeah, we'll fix it. With the music playing sometimes. I have to edit the videos after. So yeah, just let me know if there are any issues, but I'll be sure to like post once it's edited.
No, thank you. Thank you so much for having me. And for everyone who is listening, thank you.
All right. Take care and have a good night to everyone else from Chicago. All right.